Okay, so we are going to be working on trig functions of any angle, part 1. Okay, so we're going to start with a little review of the trig functions we've been working on. So standard position, remember, of a angle. We start on the x-axis, that's our initial side, and then it opens up from there. So typically we call that angle theta. Sometimes you call it x. Sometimes you can call it any other Greek letter. So that's our standard position when we start on the x-axis. Okay, so a quick review. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is the reciprocal of tangent, so that would be adjacent over opposite. Secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. And then cosecant is the reciprocal of sine, so that would be hypotenuse over opposite. So let's look at an example. Number 1 says, let -3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So first, we got to figure out what quadrant we be working in. -3, 4 would mean I'd be going left 3 and up 4. So somewhere in the second quadrant would be my point, -3, 4. So I'm going to make a triangle that would be in the second quadrant. Okay, and I'm going to label my angle. So the angle is always the distance from the x-axis up to my point. I'm going to label that theta. And I'm going to find sine, cosine, and tangent. So first thing I need to do is find all 3 sides of my triangle. So I know 2 of the sides already. I would have to go to the left 3, so this side is -3. And then up 4, so this side is 4. My missing side, the hypotenuse, would have to be 5 because this is a 3, 4, 5 triangle. Or you can use the Pythagorean theorem. Okay, so next thing I'm going to do is find sine, cosine, and tangent. So sine of theta, opposite over hypotenuse, so that would be 4/5. Cosine of theta, adjacent over hypotenuse, that would be -3/5. And tangent of theta, opposite over adjacent, so -4/3. Okay, let's try another example. So number 2, given sine is -2/3 and tangent is positive, find cosine of theta and cosine of theta, cotangent of theta. Okay, so first I gotta figure out what quadrant we're in. So sine is -2/3 and tangent is positive. So one thing we wanna think about is where certain trig functions are positive. So I'm gonna make a coordinate plane over here in the corner, and I'm gonna just draw some labels here. So in the first quadrant, all of the trig functions are positive because any point in the first quadrant you go over and up, so any answer would be positive. In the second quadrant, sine is positive and cosine and tangent are negative. In the third quadrant, tangent is positive and sine and cosine are negative. And then in the last quadrant, cosine is positive. So if you remember it this way, you can remember which quadrants each one is positive in and all the other ones are negative. An easy way to remember this is use the mnemonic device, all students take calculus. So if we're looking at this first example here, I want to know where sine is negative but tangent is positive. Well, that would have to be over in the third quadrant. In the third quadrant, tangent is positive, but sine is positive, negative, but tangent would be positive. I'll say that again. So in the third quadrant, tangent is positive, but sine is negative. So when I draw a triangle, I'm going to draw a triangle that's in the third quadrant. And I'm going to label my angle theta. So the two sides that I know, sine is opposite over hypotenuse. So the opposite side is -2. Hypotenuse is 3. Now, one good question that people might wonder is, how do I know which one gets the negative? Well, hypotenuse is always positive because you square two numbers to get the hypotenuse. And if you think about this, you're going to the left and then down. So if you're going down, this number should be negative over here. So that also means that my top number here should be negative as well. So I've got to solve for that missing triangle side. So -2 squared plus b squared equals c squared. 4 plus b squared equals 9. B squared equals 5. B equals plus or minus 5, but it's going to be a -5 since I'm going to the left. -√5. So I'm going to find cosine and cotangent. So cosine of theta, adjacent over hypotenuse. And then cotangent of theta, cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent would be adjacent over opposite. So the adjacent side is -√5, opposite side is -2, so that's √5 over 2. So that should fit. Tangent is the only thing positive. Cotangent is the reciprocal, so that's going to be positive as well. But sine and cosine are both negative in the third quadrant. Okay, let's try another one, number 3. Evaluate the sine and cosine functions at the angles of 0, pi over 2, pi, and 3 pi over 2. So these are all quadrantal angles. We've talked about this before. They're right on the boundary. So let's make a list. I'm going to find sine of 0 and cosine of 0. I'm going to find sine of pi over 2 and cosine of pi over 2. I'm going to find sine of pi and cosine of pi. And sine of 3 pi over 2 and cosine of 3 pi over 2. So if you don't remember what these are, you have your unit circle to look at. So 0 is over here. Sine is the y. So the y value at 0 is 0. The x value is cosine, that's 1. Pi over 2 is up at the top here. The y value is 1. The x value is 0. Pi is over here on the left side. The y value is 0. The x value is -1. And then 3 pi over 2 is down at the bottom. The y value is -1. The x value is 0. Okay, this last part we're going to talk about reference angles. Now we've been using this all along, we just haven't called them reference angles. So a reference angle is, let's say you have an angle like 150 degrees, and you want to know the sine, cosine, and tangent of 150 degrees. Well, that's an angle in the second quadrant, but we can't make a right triangle out of that. So what we've been doing is making our angle, our right triangle, drop down to the x-axis, so we would be calling that theta. And we've been using our right triangle trig to solve. So we've been doing this right all along, but what we've been doing is using a reference angle. A reference angle is the angle that measures to the x-axis. So it's the angle between the x-axis and our terminal side. So right now I'm going to go to the graphic organizer that we have for reference angles. And we're going to draw some reference angles and explain what this means. So flip to your reference angle graphic organizer. It says reference angles at the top. And we're going to start in the first quadrant. So any angle that ends up being in the first quadrant is fine, right? If we make a right triangle in the first quadrant, I don't have to change anything about it. It's automatically a right triangle. So in the first quadrant, our reference angle, and I'm going to use alpha as my reference angle. Alpha is the same thing as theta. Okay, next let's say we have an angle that ends up being in the second quadrant. So I'm going to mark an angle that goes all the way over into the second quadrant. So we got theta here. I'm going to call this angle alpha, the angle that is between the x-axis and our terminal side. So now we'd make our right triangle. Now if theta is the big angle, let's say that was 150, we'd want to know alpha. If I want to figure that distance out, I would just subtract that from 180. So I'm going to write a formula up here. Alpha equals 180 minus theta. And that gives us that distance up to the terminal side. Okay, next let's say we have an angle in the third quadrant. So we're going to start here. We're going to go all the way around to the third quadrant. So we've got our theta, and alpha is this little distance back to the x-axis. So now I can make my right triangle. But to evaluate alpha here, we would take theta minus 180. Then in the last quadrant, I would go all the way around, end up in the fourth quadrant. If I wanted to make a right triangle, I'd need alpha here. So to get this little distance back to the x-axis, we would take 360 minus theta. Okay, so I'm going to do the top part here so you can see the whole top. And we'll scroll down to the bottom part here so you can see the bottom. Okay, so let's practice trying to find a couple reference angles. So let's look at number 4. Number 4 is 300 degrees. So that is in the fourth quadrant. So if I want the reference angle, I'm going to use the formula 360 minus theta. So 360 minus 300 gives us 60 degrees. So you're right as long as you get an angle less than 90, because that means that you would have a right triangle. Okay, let's go to number 5. Now number 5 is in radians. So we have to think about where 2.3 would be on the unit circle. So if we're working in radians, pi is over here, that's 3.14. We've got pi over 2 up at the top, so that's half of 3.14. So we're going to be in the second quadrant. So I'm going to use my reference angle, 180 minus theta, but we're going to use radians, so that would be pi minus theta. So we're going to do pi minus 2.3. And we'll round to 3 places. That would be 0.841. Okay, number 6, negative 135. So that's definitely not an angle on a right triangle. So first thing I'm going to do is get a positive angle. I'm going to find a coterminal angle. I'm going to add 360 to that. That gives me 225. So 225 is in the third quadrant. So I'm going to use my formula for the reference angle in the third quadrant, theta minus 180. So that's 225 minus 180, which gives us 45 degrees. Okay, so that concludes part 1 of our trig functions.